Juliana Harding, and this is my astronomy project. So here's the cosmic address, and we're on Earth. And then this is the solar system. And we have the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto's a dwarf planet. So that's the solar system. And then the Milky Way galaxy contains our solar system. And the Milky Way is a bar-shaped galaxy that is 100,000 to 120,000 light years in diameter. The Milky Way contains 100 to 400 billion stars, and we're somewhere in here, like right there. Okay, and then right here is the local group, and the local group is a group of galaxies that contains the Milky Way. The local group contains 54 galaxies. The center of the local group is between the Milky Way galaxy and the Andromeda galaxy. And then over here we have the Virgo supercluster. The Virgo supercluster is a cluster of galaxies that contains the local group, Milky Way, and our solar system. The Virgo supercluster is made up of at least 100 galaxies and clusters. It is 110 million light years in diameter. And then over here is the eras of the Big Bang. And we have the Planck era, and the time is 10 to the negative 43rd second. And the temperature is 10 to the 25th Kelvin. And scientists are unsure what happened in this era. And then here's the Gut era, and the time is 10 to the negative 35th seconds. And the temperature was 10 to the 13th degree Kelvin. Era was under extreme temperature and density. Strong, weak, and magnetic forces were unified. And then we have the Electroweak era, and the time is 10 to the negative 10th second. The temperature was 10 to the 10th Kelvin, and the universe was small, hot, and dense. Protons and neutrons started forming from quarks, and radiation fills the universe. And this is the Particle era, and the time is 0.001 seconds, and the temperature was 10 to the 9th Kelvin, and the electrons started forming. And then the era of nucleosynthesis, the time is 3 minutes, and the temperature was 3,000 kelvins. The universe began to cool, and the protons and neutrons began to bond. Quarks and gluons form protons and neutrons. And the era of nuclei is the time 300,000 years, and the temperature was 20,000 Kelvin. Protons and neutrons began to bond and form hydrogen and helium. Energy, density, and matter became greater. And the era of atoms the time was 1 billion years. The temperature was 18,000 Kelvin, and hydrogen and helium formed to create the first star. And then the era of galaxies. The time is 13.7 billion years, or current, and the temperature is 2.73 Kelvin. Stars and galaxies form. Our sun and earth are born. And then over here is CMB. CMB is like all over, but that's just a little area. And it's also known as cosmic microwave background. CMB is the thermal radiation left over from the Big Bang. It is located everywhere in the universe. And then right here is Hubble's law. And Hubble's law describes the expanding universe. Hubble's law is the direct correlation between the distance to a galaxy and its recessional velocity, or redshift. The dot represents our universe and everything expanding away from us. And then here's the Shapley supercluster. And the Shapley supercluster is the largest concentration of galaxies in our nearby universe that forms a gravitational force that pulls itself together rather than apart. And right here's the Sloan Wall. And the Sloan Wall is a cosmic structure formed by a giant wall of galaxies, or a galaxy filament. And then filaments are like the lines. Filaments are among the largest known structures in the universe. They are massive thread-like formations that form the boundaries between large voids in the universe. Filaments are typically 163 to 261 million light years away. And voids are the empty space. So voids are vast empty spaces between filaments. They contain few or no galaxies. And then dark matter's all around. Dark matter is a kind of matter that cannot be seen but accounts for most of the matter in the universe. Dark matter is thought to surround the outside of the galaxies in the halo. And then over here we have the Great Attractor, and the great attractor is pulling our universe and other universes toward a specific part of space. It is about 150 million light years away. And then over here's redshift. Redshift occurs when light or other electromagnetic radiation from an object is increased in wavelength or shifted to the red end of the spectrum. Redshift occurs when a light source moves away from an observer and is evidence of an expanding universe. And then right here's a saddle universe. And the saddle universe shows an open or negatively curved like a saddle. And then over here's a 3 torus universe. And the 3 torus shape of the universe is like a donut that makes up the entire universe. The 3 torus as a large structure represents an infinite structure where the universe never ends. And then over here's the flat universe. And looking at the universe nearest to us, the universe looks flat. However, when we look further out, it looks curved like a saddle. Thank you for watching.